Chessboard, where is this, where have we seen this before? Where is this familiar? Jose?
From problem 1.1, requesting a reward. It was when the king was requesting a reward to the president, and on the first square there was one ruble, and then it kept doubling each square.
Right, and they were placing those rewards on the chessboard. Who remembers the ballot problem? When we first started this book on exponential growth, who remembers the ballot problem? Giselle, tell me about it.
I think one of the students, he was supposed to make ballots in order to create a student council. So he had a sheet of paper and cut it in half, and then it grew into a pattern of doubling each time.
Doubling, okay, pattern of doubling. Someone go to the board. Let's remind us of what was happening when something was doubling. So Giselle, you said that we started off with this one sheet of paper, which was considered one ballot. What happened once we cut that in half?
It became 2 ballots.
So Carla, can you do me a favor? Let's start recording this to remind us. And what happened from there? But once we had 2 ballots, we went ahead and we made another cut. And BJ, what happened?
It became 4, kept on doubling.
Kept on doubling. Okay. So someone continue. Tell Carla what's going on so she can record this. Someone let Carla know. Yeah, go ahead. Say something. What's going on?
Every time, for every 1 square number, it doubles by itself. Like for example, 2, 4, 8, 6, 2, 4,
Okay,
8.
let her know so she can record this.
So first one's 2.
Next one's 4.
8,
8,
16,
16,
32,
32,
64.
64. 64.
Okay. So every time the number of ballots were doubling. Okay. We're going to kind of combine these 2 problems. Look at this chessboard, which is familiar to you, and let's think about what was happening with these ballots when we were cutting it in half. What's the area of this square?
64.
How do you know? How do you know?
Because there's 64.
Did you count every individual one? Then how'd you know?
8 by 8.
Because you multiply 8 by 8.
Oh, okay, so we looked at length and width and we said this is 8 by 8, so 64 squares. What do you think would happen if we cut this in half? Similar to the way we did the ballot problem when we cut it in half. What do you think would happen? What do you think would happen, Allian?
32.
32? Well, how'd you get this? How'd you get this? Andy?
Because half of 64 is 32.
Okay, interesting. What do you think would happen if we cut that in half? What would happen to the area then?
16.
Okay. What do you think?
16.
16? Okay. What if we continue to do this? What do you think is going to happen to that number of the area that's going to be on the square? If we just continued to make these cuts. Jamie, what do you think? So you think the numbers are going to keep on decreasing and get smaller and smaller? Who agrees with that? Who agrees with that? Okay. Here's what I want you to do. Look at page 48 in your book. Looking for a volunteer to read the top of page 48. Thank you.
The exponential patterns we have studied so far have ongoing quantities that increase. In this investigation, we will explore quantities that decrease or decay exponential as time passes.
Excellent. So, when Amy said possibly this pattern is gonna continue to decrease, and all of you agreed, yes, it's gonna decrease, well, hey, this is what we're gonna look at today. Looking at these patterns where now the numbers are decreasing. Let's read the situation in 4.1. Carla, thanks.
In problem 1.1, read about the ballots trend. The Secretary of the Student Government Association is making for a meeting. Recall that the Chen cuts a sheet of paper in half, stacks the two pieces and cuts them in half, stacks the resulting 4 pieces and...
Excuse me?
Yes.
Is Marilyn Luna in your classroom at the moment?